Hi again, everybody. Yeah, once more, my name is Cooper Lienhart. I'm the founder of Nature's Engineers restoration business, which is local to the Central Coast. And I'm here to tell you about process-based restoration, how we can mimic beavers to restore stream health. So this is a picture right here of a natural beaver dam on the Salinas River, about 100 feet long and 4 feet tall. Oh, yes. So, so why beavers? Might surprise you that I never really grew up thinking about beavers at all. I grew up in the suburbs of Chicago. Um, and so what the first thing that got me interested that eventually led me to beavers was actually climate change. So my high school earth science class did this big project about climate change, and I was shocked by how much carbon we were putting into our atmosphere and how we had no real plan to absorb the carbon back out of the atmosphere to keep our temperature steady. So I did this research project on how to geoengineer, how to remove carbon from the atmosphere. And I thought I was going to build synthetic trees that could just suck CO2 out of the atmosphere and store it for us. So I came to Cal Poly with that in mind. I came out for environmental engineering in 2016. And through my studies and studying abroad in Iceland and Greenland, I realized that our natural ecosystems can really be our greatest allies in fighting climate change, especially wetlands. So wetlands are actually our most efficient land ecosystem at absorbing and storing CO2. So they're these huge carbon sinks. You're looking at, this is a beaver dam on the Salinas River, and that's one of our local beavers that built this dam. We call him Sal for the Salinas River. We're actually not sure if it's male or female, but that beaver is probably about 50 or 60 pounds. And one family of beavers built that dam and built a series of dams. So I learned about wetlands and their carbon holding capacity. And yeah, I'll back up.
You're still too tall.
So yeah, what makes wetlands so efficient at absorbing and storing CO2 from the atmosphere? Well, first, you have all of this ample water that's being held on the land and fertile soil. So the plant material, the vegetation that's able to grow in high densities. So as plants grow, they're absorbing CO2 from the atmosphere and storing that carbon in their wood and in their leaves. And then when this plant material dies, it oftentimes falls into the water, gets trapped under the water or the sediment and buried. And so you have this really rich, carbon-rich soil that has a lot of organic material. And over hundreds, millions of years, this carbon can get locked into the soil and buried deeper and deeper. So our big coal reserves in this country came from giant wetlands millions of years ago. And so this carbon is getting stored and the soil is being built up. And so the Central Valley of California, the Great Plains of the United States, were all vast wetlands that had been built up. The soil has been built up for millions of years, greatly because of beavers holding that water and creating these wetlands. Also, wet soil itself holds about 10 to 30 times more carbon than dry soil. So when you have this wet soil, there's the ability to have life because there's water. So you have these microorganisms and these fungal networks that are able to reach into that soil and then store carbon from the plant material through those fungal networks and be stored into the soil. So wet soil holds a lot more carbon than dry soil. One other cool thing is that beavers' chewing habits actually help cycle more carbon from the atmosphere as well. So beavers chew trees for food and building materials, but they co-evolved with these species that they eat for millions of years, 10 to 20 million years. And so when they chew these willows or cottonwoods, this is a cottonwood up here, it doesn't kill the plant. So the plant will send out new sprouts. And they send out 4 or 6 new sprouts every time they've been chewed. And these new sprouts, they taste really bitter to the beavers for up to several years. So the beavers will leave them alone and allow the tree to regrow. And so if you have a fully grown tree, it doesn't need to absorb as much CO2 because it's not grown. And so when you have a tree that's been chewed and all of a sudden needs to grow really fast and has already a well-established root system, it's sending up these new branches that are locking in a lot of CO2 and storing it as carbon in their branches. And so then years later, when the beaver decides it tastes good enough, it can chew it down and then use that inner woody material to build more dams and create more wetlands. So it's this natural cycling of carbon that the beavers are able to really accelerate. So beavers were quite abundant actually in this continent. So there's estimates that there was between 200 to 400 million beavers living in North America. So that's more than there are humans living in the United States. So they used to live in nearly every river, lake, and stream in this whole continent, from northern Mexico all the way up to the top of Canada and Alaska in the Arctic Circle. So they were absolutely pervasive. They were everywhere, and it really was beaver land in this continent. So the continent was actually about 10 to 20% wetlands. These beavers were living in creeks and rivers and transforming them into these wetland ecosystems. So a huge area of our continent was wetlands. And then when they were hunted almost to extinction, their dams collapsed and these ecosystems collapsed. And now we have less than 2% wetlands in our continent. And especially on the American West, 80 to 90% of our wetlands have been lost. So beavers were hunted because they have this extremely valuable fur. You may have seen some outside. It's really soft, waterproof, and warm. And so, and they also made very fashionable hats. So it was really the fashion trend in Europe to be wearing beaver fur coats or hats or any other garments. And so it was such a hot commodity that the whole currency of the United States was first based off of beavers. So in the Northwest, there was actually a coin called the beaver coin, and there was a beaver on it, and it was linked to the price of a beaver pelt. So the entire currency for the Northwest of the United States was based off of the currency of a beaver pelt. The first multimillionaires in this country, like John Jacob Astor, made their money off of beavers and other fur-bearing animals, but mostly beavers because they're so abundant and fairly easy to trap and hunt because you could see where their dams were and where their lodges were. So beavers were hunted so extremely that they were virtually extinct in the lower 48 states. Most of the remaining 100,000 beavers were up in Canada in the areas that was harder to get to. So California specifically, had 11 colonies of beavers left in the state by the early 1900s. So when biologists came to the state and were studying the beavers, they determined that beavers were a non-native animal. And so that we had this false idea that beavers were not native to California and that they were a pest. But through research and talking with tribes, we found that beavers actually were indeed native to nearly the whole state of California and the whole coast. Beavers on the coast were specifically hunted because Russian fur trappers came down the coast and hunted sea otters and beavers and were really pervasive in how they removed the beavers there. So where are current beaver locations in SLO County? So we do have them in our county, and they've been spreading out. So our strongest populations are on the Salinas River, from Santa Margarita through Atascadero, Templeton, and Paso, and some of the tributary creeks there. And we also have some in South County, in Arroyo Grande Creek, Pismo Creek. If you're coming on a tour of Pismo Creek tomorrow, you'll get to see some of the beaver dams there. And after the storms last winter, we actually saw beavers expand, we think, from the Salinas River Valley over the small Santa Lucia Range and into the Cayucas watershed. So they're able to expand and go large distances over land if they need to. But there's actually no official population data on how many beavers are here in the county. So the Beaver Brigade had some citizen science events where you could walk through the creek and take pictures of beaver dams and beaver signs. So we started to get an idea of how many beavers are here, but we still don't have official data on how many there are. But a pretty cool thing is we saw just a few weeks ago, a beaver made it onto Pismo Beach. So this was pretty shocking to me, actually, because beavers, they love fresh water. And they don't do well with saltwater. If they have too much saltwater inundation, the beavers could actually die. So we were very shocked to see this beaver on the ocean. Some people were respectfully taking pictures of it. But apparently it had come from Pismo Creek, swam through the ocean, went onto the beach, didn't know what to do, went back into the ocean, I think back to Pismo Creek. So here's a picture of one of the beaver dams on Pismo Creek. So we think this was one of the beavers in that family that helped build those dams. So some facts for you guys about beavers. So beavers live in tight family groups, which is pretty unusual for animals in the rodent family. And so they mate for life. At about the age of 2 or 3 years old, they find their mate. And then once they're at that mating age, they have children every year, which are called kits. And so they live in this tight family unit and raise the kits until they're about 2 or 3 years old. And then they'll send them off to find their own mate and start their own dams. So you have this family unit of about 6 to 8 beavers, usually the 2 adults, the 2-year-olds, the yearlings, and the babies. And so all the beavers help teach the children, the youngling beavers, how to be beavers, how to build dams, store food, and raise young. And so these beavers are actually the largest rodent in North America. So they can be anywhere from 40 to 100 pounds when they're adults. So that's about 3 feet long or 4 feet long even, with another foot-long tail. And they actually never stop growing their whole lives. Beavers are completely vegetarian. So their favorite food is the inner bark called the cambium layer of trees that are riparian trees like willows or cottonwoods or aspens further north. So they strip off the bark with their strong teeth, and their teeth are hardened with iron enamel in their teeth. So that's how they're able to chew through wood. And so they get most of their nutrients from the inner bark, and they also eat leaves and other herbaceous plants. And these beavers are pretty special animals because they alter their environment more than any other animal on Earth besides humans. So beavers are able to adapt their environment to their own needs. And they have these needs because they're a large animal. They have a lot of fat and meat. And so they're pretty easy pickings for any large predator, because on land, they're pretty slow and blubbery and not very agile. And when they sit on the bank, in that first picture, they kind of bowling ball shaped. They're not very quick, but in the water, they're slick and quick like a seal or an otter. So what's a beaver going to do if it finds itself in a creek that's drying out, but it needs some protection? It's going to build a dam. So over millions of years, at least 10 to 15 million years, beavers have been evolving this ability to build dams and create this deep water habitat where they can dive to safety from predators. So that's the whole reason they build their dams, is to have enough deep water where they can feel safe and escape from predators. So this is 3 images of the same beaver dam on the Salinas River at different times of the year. So again, that's over 100 feet long, 4 feet tall, built by one family of beavers. So they built this dam up over 3 years, and it just washed out last winter in those crazy storms that we had. So this was actually not the only dam they built. So they built a whole series of dams. This family had built about 8 beaver dams, both upstream and downstream of this one, and they act as like speed bumps to dissipate the energy of the water that's coming in, so that they have a more likelihood their dams will survive, and kind of a protection in case one of them fails, so they can still go to the pond behind one of their other dams. So what's pretty amazing about the beavers here on the Salinas is that the Salinas River is a fairly degraded system. And so at this time, the river often runs dry in the summertime. It's a pretty sandy river, so the water will run underground. But we've never seen it go dry where the beavers are building their dams. So they're able to keep that water year round and at least 3 feet deep of water. So it's a refuge for all of those aquatic animals that need that water to survive. And so that they also end up creating incredible fire buffers by holding so much water on the land. So this is an image from the Sharps fire in 2018 in Idaho. It burned 65,000 acres, but it could not burn that beaver habitat. So the beavers were able to spread out the water, keep the groundwater level so high and the trees were so healthy and full of water that they just wouldn't burn, even during intense wildfire conditions. Dr. Emily Fairfax is a beaver scientist who studied beavers in the Salinas River and across the West, and even in mega wildfire conditions, time and time again, the beaver habitat will not burn. So this picture, it follows a creek, and you can actually see the creek extends up to the top of the picture there, but the beavers have only built their dams in the bottom part of the picture here. So where there are no beaver dams in the top in that creek, the fire just burned right through the bottom of the channel. So all the animals, if they were able to get to this habitat, that's where they came during the fire. It was their refuge. And so if we have cities or towns along rivers like this, it's invaluable to have these wet fire buffers that can not only protect the animals, but our own communities. And they could benefit our own firefighters if you have this perimeter that won't burn, so you can surround and contain the fires before they spread. So yeah, I like to think of beavers as nature's firefighters. Dr. Emily Fairfax wrote a paper called Smokey the Beaver instead of Smokey the Bear. So yeah, they really do a lot to hold the water and create these fire protective buffers. Drought is another one of the major environmental challenges we're facing. So these two photos were taken on the same day, August 2020, deep in the drought, 6 months after the latest rainfall. And the walk, this is actually my first time visiting the beaver ponds. So it was this dry, crunchy, fire-prone floodplain. And then once we got into the beaver habitat, it was like this whole other world. It was lush and wet, full of life. Dr. Fairfax, who studied this, found that the vegetation by the beaver habitat was actually continued to get greener throughout the drought, even while the other vegetation was withering. She also found that the groundwater levels continued to increase in the beaver habitat, despite there not being any rainfall for the past 6 months. So that happens because when beavers build their dams, they're not perfectly watertight. They do leak on purpose. Water kind of trickles through, but most of the water actually gets forced underground because you have this dam with this pond behind it, and the weight of the water is so heavy that it actually forces the water underground. And so it cycles the water underground and then oftentimes resurfaces downstream, cooler and cleaner. And so you have the surface water that's being stored by these dams and the ponds, but 5 to 10 times more water is actually being stored underground. And especially on a sandy system like the Salinas River, the groundwater holding potential, recharge potential is huge. So that same process actually helps improve the water quality as well. So when you have these slow moving ponds, the pollutants, heavy metals, excess nutrients, they're able to settle out. And so some are filtered through the dam itself, but many are settled into the soil behind the pond, where the natural microbes, microorganisms, and bacteria are able to naturally process these inputs. So if you have excess nitrogen coming into a creek from farmland or rangeland, beavers are actually able to process about 80% of that excess nitrogen that's coming into the system just through the soil behind their beaver dams. And so in these systems where, especially it's coastal California, and when we get the rains, the water just rushes straight to the ocean and it takes all of these pollutants with it. If we had beaver dams in all of these creeks and rivers that eventually led to the ocean, you're not only able to slow it down and keep it on the land for longer, but you're able to provide cleaner water to those ocean ecosystems as well. So steelhead, beavers and steelhead have a pretty intimate relationship, actually. They co-evolved for 15 to 30 million years on the landscape. And so we often get asked, are these beaver dams or beaver dam analogs, are they fish passage barriers? Can fish get over them? And time and time again, it's been proven that these fish can, in fact, get over the beaver dams because they've evolved with them. So there's an old saying that beavers taught salmon how to jump. And so as beavers were building their dams, the salmon knew they needed to get upstream to spawn. And so they've developed the ability to jump great distances and get over these dams. And the smaller fish as well, if they're not able to make that jump, have often been seen wriggling through the cracks of a beaver dam and getting through that way, or using side channels that the beavers dig to get around and get upstream. There's been examples of one tagged fish that made its way over 200 beaver dams before it spawned. So they know how to get over these beaver dams. And they love the beaver habitat because it's that slower moving water, so they're not fighting against the current. And there's also abundant insect life food source for these fish. So when they live in beaver habitat, they've been found to grow about 40% bigger on average versus fish living in non-beaver habitat. So bigger fish means healthier fish populations. And so these fish are healthier and bigger on average when they're living in beaver habitat versus non-beaver habitat. And so it's not just steelhead. Beavers support a huge diversity of wildlife. So beavers are a keystone species, which means by their action, they're ecosystem engineers. So they're literally creating this wetland habitat that wouldn't exist if it weren't for their dam building actions. And so they turn these little small single thread streams into these wetlands, and then that hold water all year round. So all of these animals are actually relying on this wetland habitat that the beavers create. So if a beaver is like the keystone of an arch, if it was removed and its dams failed, then all of the water and the wildlife it supported will collapse. And so that's what makes it a keystone species. If the beaver's removed, a much smaller amount of life would be able to persist afterwards. And so wetlands are valuable ecosystem biodiversity hotspots, really. They're only 2% of our land, yet they support 80% of our native biodiversity. So they're these incredibly important ecosystems. And we actually have game cameras. The Beaver Brigade has cameras pointed at the Salinas River, pointed at the dams in the beaver habitat, and we've seen 85 different species all using the habitat. So bobcats, mountain lions, we've seen skunks swimming through the water, turtles, more duck species than I knew existed. I actually came face to face with a bobcat once at the beaver ponds. It had a rabbit in its mouth. We were like 10 feet away, eye to eye. That was exhilarating. But yeah, it's when you need water, all animals need water, and in the heat of the summer in Atascadero, it gets hot. So all of these animals will go to this beaver habitat to get a drink of water. So if beavers can do it, can we mimic them? Well, we haven't done a great job so far the past couple hundred years. So us humans, we have a tendency to like permanence, structure, something we can design and want to stay the same. So we have the tendency to want to alter our waterways and our environment around us to suit our needs. And so a lot of the creek or river restoration projects that have been implemented really have been altering the natural processes of these creeks. And so these projects are what I like to call form-based construction, not process-based restoration. So we build these huge dams, to create these reservoirs so we have reliable drinking water. Yet it cuts off the natural processes of the river and creeks. And so we see these systems degrade over time. And so lots of time and money goes into the design and construction of these projects. And we have this emphasis on permanence. We want it to stay the same. Yet these natural systems are always changing and moving. And so when they're functioning against the natural processes of these systems, they're prone over time to degradation and failure. And then huge amounts of money goes into repairing and replacing these structures. So these structures we found, haven't been the way to really restore our habitat. And so another factor is that these projects often rely on fossil fuel energy and heavy equipment. And so we spend an enormous amount of time and carbon creating these projects that really aren't long-lasting solutions. So is there another way? In fact, there is. And we just have to go back to our roots and go back to what the original stewards of our creeks were doing. So these beavers, have a process, and we humans can mimic it in order to restore health to our streams and rivers. So on the left here, you'll see as a single thread channel, maybe what you're used to seeing around this area, disconnected floodplain, fire prone. But what you can do is add these natural beaver dam analogs, these natural woody structures, which are called BDAs for short. And so you put in some BDAs into this incised channel, and it starts acting with the water. So it's starting this conversation with the channel. So the water will slow down in response to this added woody structure, and sediment will start accruing behind the structure. So then, after a major rain event, these structures, just like beaver dams, aren't permanent. You know, they're semi-permanent structures that are meant to move and change with how the river changes. So when a hard flow comes, it might bust out one side of the dams and create this sinuosity in the channel, which is what we want. So sediment's building up upon one side of the structure, and meanwhile, it's widening the channel on the other side. And so that helps slow the water down. And just like beavers, we don't stop after putting in one structure. We keep on adding more and more structures year after year. And so the next year you could come and, you know, buff up those structures that got damaged by the last rain and add more structures. So then you're holding more water and holding more sediment. And this incised channel is able to fill in more and more with sediment to the point where you have enough beaver dams or beaver dam analogs that you're holding enough water and sediment that it spills back out onto the floodplain, and you've reconnected it into its natural healthy state. And if you're lucky, and if you build it in the right spot, beavers will come in and take over your structures and do way better than us humans can, because they have millions of years of experience. They can feel the little gaps in the structures, and they can pack them with mud and clay. And so you'll have this self-sustaining wetland habitat that the beavers are able to create. So that's one thing I really want to make clear is these creeks and rivers, their natural healthy state is not just this meandering trickle. It's actually this messy, wetlandy, healthy ecosystem that you're seeing here on the right. So that's what process-based restoration is all about. It's about utilizing the natural processes that these rivers and creeks are accustomed to using. So by implementing the structure, these rivers and creeks are lacking structure and complexity is really what it comes down to. And oftentimes they don't have enough space to spread out. And so here's some examples of beaver dam analogs on a creek in the Northern Sierras in a mountain meadow. And these are actually taken 1 year apart. And this is the same structure seen from different angles. So in the first year they put the structure in, this was from Swiftwater Design, a restoration business up in Northern California who I've worked with. They built that structure, and it did a good job slowing the water down, but you could see it still wasn't connected quite to the floodplain. So the next year they came back, it had accrued sediment behind it, and they were able to build the structure higher and spread it out onto the floodplain. So in just over 1 year, they're able to go from this incised channel to one that's now connected to the floodplain, and the groundwater table is a lot higher. So it's pretty incredible how quickly these changes can be made. So all the energy, it comes not from fossil fuels, but from human labor. So people using hand tools, but most of the energy comes from the stream or the river itself. So every time when the rains come, the river is flowing strongly and eroding the banks. And so it's doing the job of gathering that sediment that we need already. We just need the human power to build these structures, or the beaver power, to build these structures that can accrue that sediment behind them, so that you're creating this complexity, building the channel back up so it can connect to the floodplain. So it's really about encouraging the evolution of the system back to its natural state. It's not a one and done process. It's not about permanence. It's about a relationship and continually working with the creek or river. So here's an example of a local project. This was the first project that my new business took on. We did it with Swiftwater Design. And this was in Monterey County, so just about 2 hours north, near the Carmel Valley. It was a small mountain meadow that released into the Carmel River. And so, excuse me, there's about 20 Beaver Dam analog or in-stream structures that we built on a half-mile of creek. So it's a high density of structures on a relatively small area. And so we built 20 structures in 5 days with a crew of about 6 to 8 people. And so here's some of us with our hand tools looking all happy in the creek. It's really fun pretending to be a beaver and build these structures. So here's a quick before and after. So this is on the left, the incised creek channel. You can not even really see the water. It was about 1 foot wide trickle of a stream, 6 inches deep maybe. But after we built this structure, which took us about 2 hours, 2 to 3 hours to finish the structure, using all on-site materials, we were able to create a pond that was over 15 feet wide and 2.5 feet deep at its deepest point. So now you have this huge pond area where you can have groundwater infiltration, and it slows it down, and it's an incredible habitat for amphibians and fish. So just with human power and hand tools and some materials, woody vegetation that was already on site, and shoveling mud from the bank, we're able to create this pond and really change the trajectory of the stream. Here's another example. We saw this stand of willows that looked like it needed some help, could use some more water. So we built a structure down here, almost 3 feet tall, and it created this nice pond to rehydrate these willows. And this was at the bottom of our build downstream. And you can see we're almost connected to the floodplain. And this is just after the first implementation. So if we're able to get funding to go back next year, we can build the structure up even higher and really spread that water out. And yeah, you can't do it without a crew of hardworking people. And I have Arturo here. He was on the crew. Yeah, so this was actually our first structure we ever built as our crew together. So we took a nice group photo. And it was just an amazing process being able to build these structures and just use our own energy. You know, the way I think about it is I wake up with this energy every day, but how can I best utilize the energy of my own body? And this is the best way I've found, you know, to use natural materials and create these wetlands, you know, almost instantaneously. So has there been any studies or research on process-based restoration? It's a relatively new practice. The first business in California started in 2018, Swiftwater Design. So it's a relatively new type of restoration practice that people hadn't considered before. Yet it creates, you know, impressive results. So we're lucky to have a student researcher, Emma Severe, research one of these project sites in the Northern Sierras where they had built 35 Beaver Dam analog structures. Sometimes the BDAs have wooden posts to support them, but sometimes you can just forgo having the wooden posts if it's not that intensive a system. And so they built 35 postless BDA structures. Here's one of them. And on this relatively small meadow. And what was interesting about it is that 2 fires had recently burned through. And 2019, it was the Walker Fire in the south end of the meadow. In 2021, the Dixie Fire burned right through the top of the meadow. And so the crew was able to get in there the next year in 2022. So it was really an exciting thing to see how this restoration could be worked for post-fire recovery. And the results were quite fascinating. So these graphs are a little confusing, but I'll help you understand. So they had these 15 groundwater wells all throughout the meadow, measuring the groundwater level. And as you can see on the top right chart here, the groundwater levels were slowly decreasing throughout the year, you know, as the summer went into fall. And then this orange bar here is the period of implementation of these 35 structures. And immediately you can see the groundwater level increase greatly in most, if not all, of those groundwater wells. So the groundwater level was significantly below the surface, and the groundwater level rose and spread out. And so they measured the water flow on both the inlet to the meadow and the outlet of the stream once it left the meadow. And so these squiggly lines on top, the sinuous lines here, pre-restoration, the inlet and outlet levels of the water matched almost exactly. But then once they put in all of these Beaver Dam analog structures, immediately there was a huge decrease in how much water was leaving the meadow. So that means it was being stored in the ponds and being stored in the groundwater. And then slowly, as the ground, as the land around the meadow became saturated with groundwater, eventually the outlet matched the inlet. So these structures aren't stopping the water. They're never taking them from downstream. They're just slowing it down and parsing it out throughout the year. So that water is more consistently staying in the meadow and reaching its downstream destinations. So this area of the difference between the outlet and inlet, they could measure how much water was stored in the meadow. And it was just over 3,700 cubic meters. So that equates to 977,700 gallons of water. So almost 1 million gallons of water were stored in this meadow just after one implementation of 35 BDAs. And so they worked for a week and a half building these structures and stored 1 million gallons of water. Pretty incredible results. And so another very interesting part of this study was that the student scientists measured the volume of the ponds that these beaver dams created. And after the first storms of the next winter, there was all of this loose sediment and ash from the fire burning the hillsides. And so a lot of that sediment and ash mobilized and went into the creek channel, which can usually be pretty disastrous for these creeks. But these structures were able to actually catch a lot of that sediment and ash. So these ponds filled in to over half their volume. So this incised channel has actually got a huge burst of sediment that was caught. And so now it's a much less incised channel and it can more easily connect to the floodplain. And fish, anadromous fish like steelhead or salmon, they can't breathe in a creek that's inundated with ash from wildfires. It gets into their gills and they choke. But if you have these structures that can settle out the ash, it actually helps the fish stay healthy and able to survive in these streams, even after post-fire conditions, even after a mega fire like the Dixie Fire. So that was some incredible data just from 1 year of work. Another really interesting study was done on process-based restoration and steelhead specifically in Oregon. So these researchers were pretty ambitious and decided to do some Beaver Dam analogs, built about 125 BDAs in this channel. So here's an image of comparing a reach that they did not touch versus what the reach looked like where they did the Beaver Dam analog installations. So there were beavers in the system there already, and they had built variable amounts of dams, never a huge number. So once the restorationists and scientists built 125 BDAs, then the beavers got really excited and they almost doubled that amount of structures. So the beavers built another 115. So you had about 250 beaver dam or beaver dam analog structures. And the cool thing was the beavers actually took over a lot of the human-made structures. So they turned them into your fully functioning beaver dams. Beavers are funny. Sometimes they'll take over a structure. Sometimes they'll go just like 10 feet downstream and build their own dam and flood out the ones the humans built. So they have a lot more experience. We're still learning. But they really appreciated, I think, having a lot more slow-moving water and structure to work off of. And so the result was it increased the pool habitat, the thermal refuge of the site, the habitat complexity was increased, and the rearing habitat for steelhead was increased as well. So they found that the juvenile steelhead survival rate increased by 52% after this project. So I don't know of any other animal that you can mimic that would help another endangered species increase its survival rate by over 50%. So this has huge implications, I think, for our area. And the other surprising thing about this study for me was that after the BDAs were installed, there was an 8-fold increase in beaver dams after this installation. So having that extra structure, I think, really gave the beavers some help, because if they're working in a degraded system where it's, the water's rushing through, their dams could wash out, every winter, and they have to start again, and there's not a lot of riparian vegetation for them to work with. It's hard to get established. But if you give them a helping hand, then they can really take off and start having more babies, producing more offspring that end up creating more dams and expanding their population. So yeah, it's a really interesting study here. So how can we apply this process-based restoration locally? One watershed that gets me really excited is the Morro Bay Watershed. It's a relatively small watershed. Watershed means any area where the rain falls and it drains to the same place. So all of these creeks drain into Morro Bay. And we are so lucky to have this Morro Bay estuary, which is just an amazing ecological spot. Yet it's facing some environmental challenges. So there's excess sedimentation filling the bay. You have these incised or degraded creeks that when the rains come, there's nothing to slow that water sediment down. So it ends up finding its way into the bay and slowly filling in the bay. There's also problems of seawater intrusion. So we are lacking in having enough fresh water being cycled underground. And so this lack of having enough fresh water cycling underground means that the seawater can intrude further and further inland, and it's actually threatening the drinking water supplies of Los Osos and Morro Bay. So if we had more fresh water being cycled underground, I think that it could help balance that out and bring the seawater more towards the ocean where it's supposed to be. Also, steelhead trout live in these streams, yet they're having a hard time. They're facing extinction. I know the southern steelhead species was just officially listed as an endangered species. So it went from threatened to endangered. I'll have to ask Steph if that's the exact species we have here locally. It's not.
Well, it is, but the designation is different south and center.
Interesting.
Delaware River South is here with threatened, but still it just became a state.
Wow. Okay, thank you for that. Yeah. Okay, sounds good. So yeah, I see all these problems in the Morro Bay watershed, and I think, well, if we had beavers, or at least Beaver Dam Analogs, that could really have the potential to address a lot of these problems, for low-cost solutions to a lot of these problems we're facing. And so there's actually a potential restoration project on Walters Creek with the Morro Bay National Estuary Program. And so Walters Creek is that small one up there, and it was actually identified as the #1 sediment source into Morro Bay. And it's actually on Cal Poly land. So if the project goes through, we'll be able to build some BDAs and see if we can hold some sediment. And there are no steelhead currently in that stream, but I'll be curious to see if they come back after we do some restoration. So that's just one of our watersheds in our county. And we have a lot. We have 25 watersheds in our county of San Luis Obispo alone, and 264 sub-watersheds. So there's a lot of potential for creek restoration and groundwater recharge in our county. So there's some local projects in the works. The city of SLO has been incredible. They have all of these open spaces, which we mentioned earlier. And on 2 of them, we'll be putting BDA implementations, hopefully this year, if not this year, then next year, on Bishop Peak open space on a small seasonal creek there. And then on Johnson Ranch open space, we'll be building 30 BDAs, and there's actually steelhead living in that creek. So I'm really excited to see how that works with the steelhead. Also, the Salinas River, we're working with the Upper Salinas Resource Conservation District they just put in a planning grant for 15 miles of restoration on the tributary creeks and main stem Salinas River. So really excited to see if we can build, probably hundreds, if not thousands of BDAs in that area. And it's super sandy and such a large system. There could be huge groundwater recharge potential and fire protection. Also, private landowners and ranchers have been approaching us and wanting projects, and there is funding and local organizations that can help private landowners make these projects happen if they have a creek on their property. Here's just some of the local organizations that you could reach out to if you're interested in a Beaver Dam analog process-based restoration project. Slow Beaver Brigade's a great one. I should put Creeklands up there too. Yeah, I'll talk about this more later at the end of the day because I think I'm running out of time. So I want you to just for a second imagine, what would a wetter beaver inhabited Central Coast look like? So I want to leave you with the Northern Chumash view of beavers. This was a message that we received, the Beaver Brigade received from Fred Collins, who is the former chief of the Northern Chumash Tribal Council. And I'll read it to you. Beaver are one of the wonders of our environment. We love the beaver. They're an integral part of all things that have to do with water, creating so many great benefits for our environment. Let everyone know we are great supporters of the sacred beavers, the work they do to bring life to our streams and rivers. They play a hidden connection to the Great Spirit and the bringing of rains, recharging our aquifers and the regeneration of life to our streams and rivers. Our sacred beavers can play a great part in climate change. Fred Collins. Thank you all. So I might have time for a few questions, but we'll be heading into breakout rooms as well.
Where's in Salinas, upper Salinas, is it north of? That's a great direction. Anyway, inland, or is it south?
So it's downstream of the lake. So which actually is north because the Salinas River flows north. So a little confusing. Yeah, yes. Can you say that again? The permaculture project? The one where I built BDAs in Monterey County?
No, that was Steph.
Oh, Steph's.
Yeah.
Yeah. That's great. Yeah, you can actually ask Steph because we'll be doing breakout rooms. Yeah.
How far do you see beavers travel?
They can travel surprisingly far. So they like to go either upstream or downstream if they can, but they'll go over land long distances. One was observed in Canada going over 100 miles. So across multiple watersheds. I don't know what motivated it to go so far. But yeah, we saw one go over the small Santa Lucia range and into a new watershed. So they can climb surprisingly well. It's very dangerous for them to be on land that long, but they do it, I guess. Yeah. That's the goal. Yeah. Oh, yes. So when we're building BDAs, do we use on-site natural materials? And the answer is yes. So if there's thickets of willow or other species, we use branches from oak trees or any vegetation that you can find. And that's the ideal, is using on-site materials. If you need to, if you're in like a rangeland where there's no on-site materials, you can truck it in. But yeah, that's the goal, is to use on-site.